I'm going to be talking to you guys today about a new type of development model that allows you to do sort of a peer-to-peer authoritative communication. It's a new way, kind of a little bit on the edge of what you might think a way to build scalable communication apps. And we'll cover the transition of the way it was originally and how we sort of gotten towards this direction to create this new type of model. Originally, data sync was AJAX and REST. So when you communicated with your end users, let's see if I can get this slide to progress here. Hold on. All right. Traditionally, it was REST and AJAX. So you had loaded the whole app, and then you had little tiny requests to go back and forth to update little components on your page. For a while, this was amazing. This was totally sufficient, and we adopted it significantly. However, we started to see a new shift into a streaming model where the client had an always-on socket connection and communicated directly to the server and back and forth. So we engineered push into the client and into our REST servers. So since this started to get adoption, that's why PubNub's here. And other open source technologies like Socket.io and SignalR, Fay, Sox.js. This new method and this new model provided a faster way to have your applications get updates in real time between users and users to servers. So it was like a push model, instantaneous update. We began to see a shift into where we saw a trend that most people were preferring this new type of model. So data, the percentage of data that was pushed increased and exceeded that of AJAX. And we saw that at the PubNub real-time network, where the growth of our customers was exceeding the traffic on real-time data push versus what they were doing with AJAX. So AJAX is sort of going the way of old, and push is the way of the new. And the advent of the available open source options that increased the uses of push sort of created a new problem. Now there's something that broke. The communication was still sent from the client to the REST server. And the REST server would do business logic and sort of calculate whether that request was valid or whether it should do something about it, and then pass it on to the socket server, which streamed it back out to the clients. So in essence, we had a middleman, a bottleneck. And as engineers, we want to remove this bottleneck because we like efficiency. Does that mean that we go to a more peer-to-peer model? And no, the answer is definitely no. It is the real world, and there are consequences to this sort of anarchy. There must be someone around to audit, but not really get in the way, sort of like direct the flow of traffic. The solution becomes clear when we start to think of an authority that's on the periphery. And this is where we come up with this new model, the supervisor. It's a server or client that sits on the periphery that listens to all the traffic, so it receives a copy and can sort of step in when needed. So it's not a gatekeeper, not a door bouncer, but more of a traffic cop. Because as you're directing traffic, you can say, okay, you guys go. And then the traffic cop just sort of sits back and waits for the flow to change, or until he needs to make the flow change. And he says, okay, stop. Now these guys go. That's sort of what this model is getting to. And so let's take a real world example demonstration of having a mobile phone control a light bulb on and off. The phone can signal the light bulb to a listener that is controlling the flow of electricity. And with the phone, you can turn on and off the light bulb. But the supervisor isn't blocking that flow. So you get super low latency of finger button fast updates to that light bulb on-off. And it also increases the simplicity of your deployment when doing this model. So in order to achieve this, we need a set of key building blocks. One of those key building blocks is a bidirectional two-way stream, full send and receive capability. Now, this new model is starting to see a way towards the supervisor, but you need more than just send and receive, sort of like standard socket connection. You also need publish subscribe. So with publish subscribe, you can broker off another connection but receive copies of data. Now we've got something that's a little bit closer to what we can get with the supervisor model, but we're not done yet because we also need multiplexing. And with multiplexing, it allows us to stream different types of data and different types of events down that same socket. And this is vital for mobile and embedded devices for resource considerations. All these transports features allows you to begin considering tracking and auditing. Now, this is what the supervisor is doing. The supervisor is tracking and auditing all the traffic that's occurring. However, they only step in when needed. And so the last component that we need is access control, something that allows us to grant and revoke on demand, sort of that traffic cop, the guy that says, okay, go now, or okay, stop, and then you guys go. So going back to that original light bulb example, we can see sort of the concept of how light occurs, or how it occurs. So say, for example, I've got control of my light bulb, but I also give control to my girlfriend. And I know you're saying, whoa, Steven, you're going crazy giving control of the lights to someone else. But I already know that I'm okay, because I have full control to revoke access at any time with my supervisor capabilities. And at PubNub, we solved this. We solved the ability to do this, and this is how we did it.
Communicate quickly, reliably, easily, remotely, and I want to do it now, don't want to have to wait. Using PubNub, super duper easy, publish, subscribe, check your history. PubNub, hub is sweeping the nation, use it in your awesome application.
All right, and now we have all the key building blocks. Yeah, thank you. All right. I've got more, I promise. So all of these things combined, we've got a full suite of capabilities, such as data push for multiplexing and broadcast and unicast through publish subscribe, mobile optimization, presence to see who enters and leaves on that socket connection, analytics for trends over time, storage and playback so you can audit in the past. And today, at this conference, we are announcing that we've launched PubNub Access Manager. This gives you full control over that grant and revoke capability on the socket connections over our channels. This is vital. This is that vital missing component that allows you to do this model. So this is sort of what it looks like. Check this slide out. I spent many hours on it. It's very complex and important looking. Quickly memorize this slide because at the end of the show, I'm going to give you a special prize. All right. Actually, I have the prize in my backpack. It's actually a really good prize. Here, check this guy out. Here you go. All right. So come see me at the end of this show, and the one who gets that slide the most accurate will get this device.
Did anybody take a picture?
What do we have to replay?
Now, can you go back? No.
I'm just going to grab the camera and replay it.
Well, we'll see how you guys do. We'll see how you guys do. But now we're going to go into sort of the coding side of things. So you sort of see how this grant revoke works. We're going to use JavaScript because that's the universal language, the most prevalent. So going through the slides here, we see that on the left, we've got a publish key, subscribe key, and a secret key. Now, the secret key is the superpower. That's the supervisor, the one that gives you the grant and revoke capabilities. Without the secret key, you can't grant and revoke. And on the right side, this is where we're issuing on the instance that we created of the PubNub object, the grant. We have the channel, the auth key, and whether we want to grant read or write permissions, or both simultaneously. And on this next slide is where we actually use the auth key. So the left side is an initialization of a user session, where we're using that auth key at the bottom rather than the secret key, which is what the supervisor had. So publish, subscribe, and the auth key. And now unencumbered, we can subscribe to any channel that we had granted on the right side. So we can subscribe that. And then when you're ready to revoke access, you simply issue pubnub.revoke using the supervisor instance. All right, so here's the next phase. Here's what we're going to do. I'm going to give myself a 3-minute timer, and we're going to see if I can code up a quick demo of how this works with the PubNub Dev Console. All right, let's see if I can get my timer running here. The first thing I have to do is get my displays mirrored. Once. All right, here we go. Here we go. That's my 3-minute timer. All right, let's see if this works. If I execute this command, everything's good. The connection should connect, and I will have granted myself access. Oh, God. Oh, no, got a stack trace. Okay, so I have a few minutes. Well, that should have worked. I know what's going on there. Oh. What's the response here? Oh, that was the 3 minutes, and it says it was successful. So what's missing? Oh well. Theoretically, if I had done this correctly, I would have been connected at this point. But I did not. Darn. Does anyone see what might be wrong with this? Let's see, you've got the channel, my channel, pub sub, secret key, pub key, sub key. Yeah. The auth key looks good. Let's see, what is... Now let's debug it real quick. So what are we seeing here? All right, why is it failing? Oh, yeah. Did I misspell pnpres? There we go. Nope, that was correctly spelled. Oh well. Sorry about that, guys. But anyway, this is the way the code should look typically, and it should work from here. But all right, so now I'm going to wrap up real quick and play my last slide. So this is the PubNub Global Real-Time Network. We connect everyone on Earth in less than a quarter of a second. And everything's written in pure C across our growing data centers. We have about 14 now. And I have a proclamation. I intend to connect every device on this earth and beyond. Thank you. All right. So what do you guys want to do now?
I have a question.
Yes.
Is this connecting clients through like a WebSocket relay sort of a thing?
That's a really good question. In terms of what the protocol is in backend, because like protocols like a WebSocket or there's many other protocols, we choose the best protocol for you automatically, and this occurs through our SDKs. So you simply just require PubNub, and then you can send and receive data easily.
Is it also capable of doing peer-to-peer WebRTC?
Yes, that's something. So there's a guy that's one row behind you or two rows behind you. Up there he is. This is our WebRTC expert. Actually, on Earth, he's one of the best WebRTC experts for data channels, which is the peer-to-peer connections. Yeah, so definitely talk to that guy. Any other questions? Sir.
Is it just P and press with 2 S's?
Oh, maybe. Let's go back to that. So here's the channel that was. So our debug purposes is pretty nice. So it says I was prevented access on this channel here. So if I go back here, I want this to work. That's the thing. My channel. All right, let's see if. No, still not happy. I don't know what it is.
We won't allow you to give away your prize unless you get that to work.
I know exactly, right? I did practice this and it was working earlier. So it says I don't have access on this channel. Let's give it a really long TTL. Still saying the same thing, but I copied and pasted it. All right. I do want it to go through. Well, we'll have to figure out what that specific detail is later.
So, most of these communication channels, like WebSockets and peer-to-peer, already have encryption at the protocol level. What's the value of doing these secret keys and other things at the application layer?
Right. So there's a lot of different types of security at all different layers. So the typical standard security these days is like 2488 SSL encryption, which is that typical handshake where you do the asymmetric key handshake and with the symmetric key. Then you do AES 256 over that connection. But doing it one step further with this, that SSL doesn't allow you to say, no, you can't grant access on this sort of resource. It's just a secure communication. With ACL or ACL level control, you're able to say, okay, only you can see the stream, even if everyone else knows what the identifiers are, except for, of course, the secret, which is the auth key. If that makes sense.
So can you describe a scenario by which they would be able to get all the other keys except the secret key if all of those keys are all in one JavaScript file?
Very, except for the secret key? Or except for the auth key?
That's the only thing that makes this layer helpful, is that they
Right.
can't get it if they don't have that key. So
Exactly.
how would they be able to get the other keys and not the secret key?
So this is what key exchange is, right? So you typically, when you're bootstrapping your users, you'll have, you'll identify them through their username and password, and then you send back some sort of generic payload, like, yes, you're who you say you are, here's your session ID. But along with that, that session ID, or you can pass another ID with it, which can be used as the auth key, which is why we let you use anything you want.
So you get a per user, the auth key or the secret key is per user.
Exactly. And you can also, if you want, give out that auth key to a large audience, because it works everywhere. And then you can say, here, this group in this room now has the auth key. I will grant you access to it, and then I can revoke it when I want.
So what's the encryption layer that you're using on top?
This is using standard SHA-256 message signing through signatures. So we're taking the request path, the channel name, a timestamp, and a few other things, and then using a secret, and then sign it. and then pass that to our origin where we authenticate this the secret. Using the same secret, we can say, yes, this signature looks right.
So it's not encryption, it's an authentication.
Exactly.
So I'm still trying to understand the scenario by which, because again, WebSockets and peer-to-peer already established through a SSL encryption.
Right.
So you can't have man in the middles or anything else like that.
Precisely.
What's the scenario by which somebody could hijack a WebSocket channel or a peer-to-peer channel, and that you would need to be able to authenticate the source?
Right. That's a great question. Because PubNub is publish subscribe, in this case, if you knew what the channel was, and you had perhaps the subscribe key, those are the only two pieces of information you need, regardless of SSL security or otherwise. Like say you embed it into your web page, for example, then I can just easily copy and paste those. So with the auth key, this gives you one step further full access to grant and revoke on any stream at any moment in time.
So those three keys that we're seeing there, you're saying that in our real app, we would not...
This would be on your server. Right, this is only your server, for example, or someone you trust with a very special URL that's running it in your browser, for example. But this is a Node.js server, for example. Yeah.
Why is this little diamond that you put here not a bottleneck? I'm just, you still have to have you're not doing peer-to-peer anymore, so
right.
Why isn't that become a bottleneck? What's the savings now?
So now you don't have to scale a large system in order to sort of front-end all of these sort of REST requests, which are very heavy, very business-driven, hitting some OLAP systems or database user systems or of whatever, and then it becomes a slowdown point, like man in the middle. But usually when you're trying to synchronize data, you want that data to go as quickly as possible. So sending that data down the tube on that, it's more efficient to send data user to user, for example, right? As opposed to straight to the server, waiting for it to spin, then deciding it needs to go into a queue, and then pushing it back out over a socket.
Okay. But aren't you sending it to HubNub and then up user HubNub down?
Well, that's the great thing about PubNub Special. We're kind of like a CDN. Well, we've got data centers everywhere on Earth, and the fastest time here at this conference that we typically get is about 15 milliseconds. So that's amazingly fast response times, and we're highly available. So we're very close, and so that hop is very short. So your data centers can be anywhere on Earth, but you'll still achieve that low latency.
So I thought you were talking about a mesh network of peer-to-peer.
Yes, and that's one step further where there's no authority. If you're doing true peer-to-peer, like I had that slide, it was like, no, you cannot do it, because then it's anarchy. And you can't really do anything in that case. But if you're trying to do real peer-to-peer, then WebRTC is your friend. If that makes sense. Yeah. All right. Any other questions?
What's the device? What's the device
It's a mini. It's a black mini.
I had another question.
Okay.
So as a service that I assume you sell, service plans to, I sign up and I pay XYZ per month to have this. If you are able to transfer data peer-to-peer, then I'm not paying you for that data. But if it's not able to do that, then I am paying you for that data. So is
exactly.
that built into the pricing structure?
So that's a really good question, and this is something that I would like to address to you. So with PubNub, we're a highly available pub sub, and so we cache and store messages. Even if the connection goes away, we make sure that the data can always be redelivered, and so that is the pay side of things. But WebRTC is this new technology that allows you to do peer-to-peer in the browser over data channels, and we really like this because parts of your data should be free. And in order to establish those peer connections, you've got an IP address over here, and then you've got an IP address over here, but you have no idea how to exchange those, those packets. Like, how do I connect? So you can use PubNub as an intermediary, very, very short term, and then
your signaling.
Yes,
PubNub for signaling.
Exactly. So we're the signaling broker, highly reliable, highly available, and then at that point, then you can say disconnect, and you've got a free peer-to-peer connection. Otherwise, other than bandwidth, right? So we really like that. Yes.
Just to confirm, I understood correctly. So besides just the push that you provide already, you also provide WebRTC signaling protocol connecting it to place.
I mean, that's a really good question. We like the WebRTC protocols. It's open source, and they're like peerless, right? So peer-to-peer, there's no middleman of any kind, and that allows you to do free communication between those two. And that is embedded in browsers these days. So you can use that capability to, establish links. Using PubNub as a broker, for example, to signal what IPs need to go where. But that's just the handshake.
Are you going to stay just for the handshake, or okay, and then you go away?
Yeah, it's up to you. Like if you want to stay on, like say the connection gets fuzzy, or you're on a mobile device and your IP address changes, you'll need to re-exchange that signal. If that makes sense.
How does that work for retry? You said for example, the subscriber goes away, the publisher sent a message, you retry,
Right.
it goes up again 2 days later, you got the message gap.
Exactly, and that's configurable by you. So if, say, the device goes away, it loses its connection, but it's desperately trying to grab on to a network, it eventually will grab that network, and any messages that it had missed during that time will automatically be recut up for you. Yeah. All right. So I was doing some debugging here. It goes through, but I don't know why it's not getting the grant action going on. Anyway. All right. Any other questions? Who wants to challenge themselves for the iPad?
What's been the condition? Do you remember that diagram?
Yes, exactly. Those of you who can get the closest.
I mean, the diagram was the customer PubNub.
Mm-hmm. And
It's not going to be fair.
oh, you might win. You might win in that case.
I
Yeah.
remember there was a box in the bottom left-hand corner that had a bunch of little nodes in it.
Mm-hmm.
And then there was an arrow up, and it said customer somewhere.
Yeah,
Yeah.
your enterprise architecture, it was your
Exactly. It's supposed to be complicated and important looking.
enterprise architecture.
A whole bunch of penguins across the top.
Different data centers,
Precisely. Yes.
and your encryption layer, and
Mm-hmm. Yeah. Lots of security layers there. So I'm still scratching my head about this because I totally made it work earlier.
I think the guy with integrity who told you he had a picture gets extra points for that.
Yeah, definitely. You're like ahead of the curve.
Extra points.
It's like good
Give
student.
the iPad to the person that debugs your code.
Take a look at
Yes. All right. Who's got the challenge on getting this to
So
work?
whoever helps you solve this problem to get it to run gets the iPad.
If that's something that we can all agree on, the one who gets the answer to this.
have you repasted the keys?
Okay. Okay.
Have you repasted the keys from your
All right. Let's give that a shot.
web page?
Let's copy and paste the keys to make sure they're the right keys.
Because you look like somebody who's written this code before.
Yeah, I did this earlier. All right, that one looks similar and the same. Let's try this one next. Okay. Paste. Okay. PubSub PubNub. My channel. ABC. Let's change the channel to like something very simple. 34.
Can you change the channel name? Maybe you use the channel in some other than.
What is -pn press
So
indicated?
we've in our dev console, we've got two channels that we're using, multiplexing. We've got a standard channel and then a presence channel, which is a sister channel that allows you to get analytics on who's connected on that channel other than you. And it gives you an occupancy count. And that information shows up here. If that makes sense. All right.
He's not using the revoke function.
Yeah, not yet.
Oh, I see. You call them up there, you call the grant up there.
API key or auth key or something.
Auth key.
You didn't copy and paste that.
So you didn't copy and paste all the keys.
Device authorization. Other.
Yeah, ABCD there. Can we verify that in the
Is off key a public variable?
Let's try it out here. Let me shrink that down a bit so we can see it a little better.
It is, yeah. Try it.
All right, let's give it a shot. Nope. Should call the engineer who made this. Yep.
Can you see in the logs that you're getting something across?
Yeah, I am printing out the response, and it's saying that I've granted successfully.
Yeah, what about a port or something? I mean, this thing's up. It's you're running on some particular port. Maybe it's
Whose network, right?
Right. Resize. This 20. Let's get there. Let's print out better. Let's do JSON.stringify. Oh. Okay, I figured it out.
Okay, no.
Yeah, I'm gonna let you guys figure it out.
Can figure out what you're figuring out.
Okay. It was the silliest thing. Okay. And it was also on the slide. All right, first one to figure it out gets an amazing iPad. No, you can't do it, Dan. No. No. You're an employee. You can't do that. It's not fair.
Is it that you're not specifying a level?
Can you describe that further?
Well, in those JSON responses that says level user, I was thinking maybe you need to grant that level in your grant statement.
Close, but no. You're on the right track.
Dun, 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 dun.
your TTL doesn't match.
Missing a secret key?
Nope, secret key's there. A, B, C, D. And the answer is on the screen. All right, if 3 minutes. Yeah.
Action join.
Nope. Oh, one of those. Okay. You're super close. Almost. You have to use the exact words. This was on the slide. You can also look it up the documentation. It's on the website. That is remarkably close. There's one parameter missing. Not secret key. Nope. All the keys are good. Not the keys. Yeah, keep going. You're so gross. Oh. Yes, the supervisor has full security credentials. It's ready to go. He just needs to say one more thing. It's also, yeah. Supervisor is authorized, yep. But the supervisor needs to grant the authority on the auth key by specifying one more parameter. All right. Channel's there. All right. So I'm gonna type one letter, and the first person who shouts it out gets the iPad. Are you guys ready? Almost. I'm typing it in slowly. Oh, you got it. That guy got it. Good job. You're so close. You were trying really hard. Well, wait, before, let's make sure it works. Let's set read true.
Did wonder about the L0.
Oh, he doesn't get the iPad. So.
Oh, I had the wrong channel. All right, it works. There you go. All right, thanks, guys. Sorry about that. All right, come claim your prize. Thank you. Good thing you made it.
Thank you.
Yeah, definitely, yeah. All right, thank you, guys. Thank you.